Here we have the definite integral of x squared minus 4, and we want to evaluate it from -1 to 1. And what this definite integral, it represents the area between the graph f of x equal to x squared minus 4 and the x-axis from -1 to 1. And so that's what it represents. And so this is what it looks like. So this is the graph of the function x squared minus 4, and this is the area from -1 to 1. And notice that this area is below the x-axis, and therefore the definite integral, the value of the definite integral will be negative. And so to evaluate this definite integral, first we need to find the antiderivative of f of x. And normally we call the big F this is the antiderivative of f of x equal to x squared minus 4. So the big F is defined as the antiderivative of the small f. And we have the fundamental theorem of calculus. It says that this and the definite integral is equal to the antiderivative at 1 and then minus the antiderivative at -1. And so this is from the fundamental theorem of calculus. And so first we need to find the antiderivative of this function right here. And recall that to find antiderivative of x squared, then we add 1 to the exponent and then dividing by whatever we get. And so we have x squared, then add 1 to the exponent, then we get x to the third, and then divided by 3. So 2 plus 1 is 3, and then dividing by 3. And then the antiderivative of a constant is just the constant times x. And then we can always check to see if we got the right or the wrong antiderivative. If we take the derivative of this function, then it will be x squared minus 4. And so no. The derivative of the antiderivative, this is equal to x squared minus 4. And so now to get the area between the graph and the x-axis, then we need f of 1 and f of -1. And so f of 1, this would be 1 to the third divided by 3, and then minus 4 times 1. And this comes out to be -11 thirds. And then we need f, the antiderivative at -1. So this will be -1 to the third dividing by 3, and then minus 4 times -1. And this will be 11 thirds. And so the definite integral will equal -11 thirds minus 11 thirds, which is negative 22 thirds. And again, the definite integral, it has a negative value if the area is below the x-axis, and it has a positive value if it's above the x-axis. And if if the area, some of it is below and some of it is above the x-axis, then it will be positive if there's more area above the x-axis, and it'd be negative if there's more area below the x-axis. So this definite integral here, it has a value of negative 22 thirds. Here we have the integral of 3t minus 1 squared, and we want to evaluate it from 0 to 1. And so again, this definite integral right here, it represents the area between the graph of the function 3t minus 1 squared and the x-axis from 0 to 1. And so to find this definite integral right here, we need to find the antiderivative of the function f of t. And so let's look at the graph first. This is the graph, 3t minus 1 squared. And this is the area from 0 to 1. And so that's what this definite integral, that's what it represents. And the fundamental theorem of calculus, it says that this definite integral it will be the antiderivative evaluated at 1 minus the antiderivative evaluated at 0. And so first we need to find the antiderivative of this function right here. And so before we do that, let's go ahead and multiply this out. So this would be 3t minus 1 times 3t minus 1. So it would be 9t squared minus 6t and plus 1. And so the antiderivative of this function right here, if it's 9t squared, then it'd be 9 times the antiderivative of t squared. And to get the antiderivative of t squared, add 1 to the exponent, which is 3, and then dividing by 3. And so basically, antiderivative, we just do in the reverse of what we did with derivative. And then minus, this is 6 times t, so minus 6 times this is the same as t to the first, and so add 1 to the exponent and we get 2. So this is t to the first, so add 1 to the exponent, we get 2, and dividing by 2. And then antiderivative of a constant is of 1, it's just 1t. And again, if we take the derivative here, let's go ahead and simplify it, and then we take the derivative. And so f of t, 9 times t to the third divided by 3 would be 3t to the third. And then minus 6 times t to the second divided by 2 would be 3t to the second. And then plus 1t. And if we take the derivative of this function, of the antiderivative function, then it will come back to the small f, the function. And so that's the relationship between the small f and the big F. And now we need the the antiderivative at 1 and then at 0. So first let's evaluate it at 1. And so this comes out to be 1, and then we need to evaluate it at 0. And this will be 0. And so the definite integral, this will be 1 minus 0, which is 1. And so we look back at the graph, then the area between the graph and the x-axis should be 1. And right here, we have an area of 0.9999, which is 1. And so again, that's what this definite integral represents, the area between the graph and the x-axis. And this area right here is 1. The exact answer is 1. Here we have the definite integral of 5 dividing by x minus dividing by x to the 4th minus 8. And the lower limit of integration is 1. The upper limit of integration is 2. And again, this definite integral right here, it represents the area between the graph of 5 divided by x to the 4th minus 8 from 1 to 2. And so this is what the graph looks like. So this is the graph of the function f of x, and this is 1 to 2, and this is the area we're looking for. And notice that the area, the shaded region, is below the x-axis. This is the x-axis, and therefore the area, therefore the value of this definite integral will be negative. And so let the big F be the antiderivative of this function right here. It should be minus 8. Be the antiderivative, the function 5 divided by x to the 4th minus 8. And so the once again, the definite integral is equal to the antiderivative evaluated at 2 minus the antiderivative evaluated at 1. And that's by the fundamental theorem of calculus. And so before finding the antiderivative, let's go ahead and rewrite this. Recall that this is the same as 5 times 1 over x to the 4th minus 8. And so this becomes 5 times x to the negative 4 minus 8. So 1 over x to the 4th is the same as x to the negative 4. And so now let's find the antiderivative. So once again, the rule is this is 5 times x to the negative 4. So the antiderivative would be 5 times. Add 1 to the exponent, so negative 4 plus 1 would be negative 3. And then dividing by negative 3. and then minus the constant a, the antiderivative be just a times x. And so here we get negative 5/3 and then x, and then negative 3 and then minus ax. And so this is the antiderivative. And once again, if we take the derivative of the antiderivative right here, if we go through and do the antiderivative, then it will be this. And we can see it right here. Remember, to take the derivative, we do the opposite. We do the reverse, which is subtract 1 from the exponent. It'd be negative 5/3 times negative 3, and then subtract 1 from the exponent, and then we get 5x to the negative 4. And then the derivative of a times x is just 8. And so now we need the this part right here. And so we need f of 2. So in the place of x, we would put 2. And then if we do this, this will come out to be negative 389 over 24. And then the antiderivative evaluated at 1, then we will put 1 right here. And this will come out to be negative 19/3. So this is equal to negative, so it'll be this right here, minus negative 19/3. And this will be negative 79/8. And again, the definite integral has a negative value, so that tells us that the shaded region is below the x-axis. And we can look at it again, so we can see that the shaded region right here. So this area right here is 79/8, but it's below the x-axis, and that's what that negative right here is for.